for listening.
Thank Dante.
Just a small message for you. I have been, I'm very, very grateful to Lexical for giving me the opportunity to visit. But this is my first time in Donosti. I have been several times in Germany. So for me, it was very important in my career, but also as a person. So I want to return the favor to you and invite you to come to Argentina, because Lexical is also supporting your traveling to Argentina. And I think that very little Europeans are flying in the opposite direction. So I offer in my services. I mean, Argentina is a huge country, but also Chile, also Latin America in general, and there are a lot of things to do there. So these are all shots taken by me, so I can give you I can be your tourist agent, and also perhaps we can collaborate scientifically. So that's my invitation. Okay, thanks. Okay, so
Are there questions?
I maybe have a question, because I was a bit confused with one of the statements you made, and when you were talking about the baryon contents of galaxies inside voids, you said that they are the galaxies inside voids tend to be metal poor and young, which is kind of like, I don't know, to me it feels counterintuitive, because like you would associate like metal poor stars as being old stars. So how could you have something that's metal poor and young?
Yeah, I think that also it depends on if you are modeling the metallicity of the, I mean, is the metallicity of the population, I would say. And the metallicity of the population also weighted by luminosity. So that's also another important detail, because you have here in each pixel, you have a population synthesis of all the spectrum. So you have a statistical population of stars. And well, saying that, I think that the thing is that the whole history of galaxies in voids have been very quiet and very tranquil. I mean, it's something that evolved slow in time, so it's releasing less metallicity in the environment, because they have always been with low star formation rates, but they in comparison with galaxies that are already quenching in high density environments, the galaxies today in voids, they keep forming stars. So that's the reason why most of the populations is ensembled later. So that's the reason why they are younger in terms of the mean age of your stars, because the stars were assembled late. And at the same time, given that your old star weren't so much, I mean, they have released less material to the intergalactic medium, and the medium is less enriched. So I don't know if that's a sort of explanation, but for me.
Okay, thanks.
Okay. Yeah, I'm very cautious, because I have presented these also results, and I have get a lot of criticism. So I think that.
Genuinely curiosity, I think. That's all.
I was curious in the process of the statistical inference that you do when you do Gaussian regression. So essentially, you are limited by the number by the abundance of the data that you are working with. And I was wondering, which is the threshold limit that you can, for example, like this, if you perform k-fold regression, eventually you can just like iterate over every element of your data set. Is that a limit for your training set in this case, as a computational limit?
Yeah, it's a sort of limit, but also I have I have performed this, I think, nasty trick that was grid each simulation box and shuffle these small blocks to produce different samples. So basically, you can estimate the void-side function in a fraction of your box if you want, and that gives you a more atomic representation, and then you can erase the data farther than a single node. But the problem is that you can produce independent samples. All the samples are lying in the same node in parameter space. So the question is, yes, I am limited by the number of the simulations. So one of the ideas was to I went to Germany. I was working with Ariel in this problem, and Ariel have recommended me to use the evolution mapping approach. That I don't know, perhaps I'm very ignorant, but in some way similar to the scaling relation that Raul have already developed, in the case that you are identifying the generacies in the cosmological parameter space that allow you to rescale simulations or to select simulations a given cosmological run, and then you can produce several other in the parameter space. Or perhaps you can change the parameter space to a parameter space that is not degenerate, and then you reduce the dimensionality. It's a matter of choice. You can produce more simulations box with a scale simulation, or perhaps you can change the parameter space to reduce the dimensionality. And I'm trying to do this with the FR simulations. But the problem is that this gravitation, these parameters like the FR0 is a parameter that is also depending on other parameters. So the degeneracies are not very well explained. So I'm studying this because it depends on age and depends on several things. So I can't figure out exactly what are the scaling relation for FR yet. But if I were able to do this, I will be able to more efficiently expand the training set. And perhaps also, and Raul have already suggested me to use these fast codes using GPUs and try to run modify gravity or run more simulations. So I'm open to any idea.
I guess you can test very quickly whether the number of simulation is the limiting factor by reduce your sample by 20% or so, and see whether you can start seeing some behavior that scales with the number of simulations used in the training.
Yeah. I have already studied this, and I got this overfitting when I take too much data in some parameters, but in FR0 I never got this overfitting.
So, but I mean, like whether you start getting biases in your posterior or FR.
Yes.
I mean, it's hard. I mean, I would guess that this has to do more with the likelihood you're defining rather than with your training data. I think typically, I don't know with this K-fold and CMC, but when you use ABC or more generalized simulation-based inference, the lack of simulations simply tend to overestimate the size of your posteriors. I don't think you expect it to create biases, as the ones you're seeing here. So, yeah.
Okay. Yeah, sometimes sometimes also you can get these things, and perhaps the likelihood is underestimated perhaps because the model have a huge error in that part. I mean, yeah.
So my question actually is, as you know, right? So voids have been promised as a great cosmological tool for like a decade or so. But I think my impression that they somewhat have failed to deliver on the cosmological part, right? I mean, I know for lambda CDM, they don't seem to provide that much information compared to even like simple power spectrum.
Yeah, I think that the problem was the treatment of the systematics. They were at the beginning underestimated because the people said, "Oh, this is going to be easy because voids are very linear." Also, the non-linearities in voids are present in a way that are different because the flow is not turbulent. They are in a nice expansion, but the relation between velocity and density is away from the linear model because they are very underdense. They are very underdense, so they are non-linear. And I think that the people have in some way mislead the analysis without taking into account all these systematics. Also, the problem of bias for me is the most important problem when you deal with data because the bias is very different in voice. We have already worked on that, and I think that that's the main important problem with voice.
But even if that gets solved, do you think would be? I mean, how do you see the future of voids? You think they're still providing complementary and potentially a discovery?
Yeah, I think.
Because in terms of FFR, which is another thing that what people have suggested, voids might be very good at. I think the type of constraints that you get are not that different than what you get even with normal statistics.
Mm-hmm.
So that's why my question is like, how do you see the future? Is it going to be that you need to solve these problems and then things will be great, or would be more on interesting in the questions that you were posing, like how galaxy formation is different? I mean, can we detect primordial magnetic fields and so on? So which of the two you think would be?
Yeah, I think
the future.
In one hand, yeah, for me, I think is the both aspects are going to be promising. I mean, if you look, for instance, if you take into account, I don't know, the LST data, the Rabin data that is going to give you a huge population of dwarf galaxies with, I don't know, 2 magnitudes lower than you get in DESI or Euclid or Redshift survey, you're going to get galaxies very, very faint. And even when you identify voids in Redshift space, you are going to be able to populate the interior of voids with galaxies. Perhaps with Redshift that are going to be very noisy because photometric Redshift are a nightmare. But even though we are going to get a lot of data of dwarf galaxies and low surface brightness galaxies and small galaxies in the interior of voids. And I think that is going to be a good window of opportunity to galaxy formation because the explanation of the history of that galaxies is less messy than in high density environments, and is going to reveal in a more striking way if you are, I don't know, overthinking mechanism like feedback or over. I mean, in the case of galaxy formation volume, in the case of cosmology, I think we still have something to give, and I think that the people is for the moment less, I would say, less ambitious with voice. They are more pessimistic because there were a lot of papers saying that this was going to be easy, and we end up singing the song of Coldplay. So, and I think that even though if you model correctly the bias and if you model correctly all the systematics, I think voids are going to give a good opportunity because the surveys are going to grow a lot in volume, and you will have better than ever volumes to test voids. That basically is the dominant element in volume. So yeah, we have to recalculate our expectations, but at the end, I think it's going to be important in the future. I'm still working on that, so I'm still asking for money with this project. So, what I can say.
Okay, I guess that's it. No further questions. So then let us thank Dante again.
Thanks. Sí, yo creo que tengo algo, puede ser que esté, yo creo que es el livelihood. Es el livelihood, decir. Esto de que yo hago las dos covarianzas, que yo hago la distancia, sumo las dos covarianzas al cuadrado
No, eso está bien.
y
Como que
tomo
tienes
la,
que